I wanted to take a few minutes to go over the rest of the algebra in the trig. I'll probably pop it into two separate videos, but we'll take a look and see how long it's taking to do stuff. And I'm going to kind of set a timer. I don't want to make the videos too long, so you don't have to, page through a 30-minute video to try and find what you want. Where we left off here was with rationalizing the denominator. So when we talk about rationalizing, we really don't want square roots sitting down there in our denominator. So what we're going to do, if I zoom in a bit here, what we're going to do is we're going to multiply both the numerator and the denominator by the same number. And what I'm going to do is I'm going to match the number that I have here. So I'm going to multiply by the square root of 5 over the square root of 5. I know I wrote it backwards, but it's just matching it up. If I do that again, when we multiply fractions, we multiply numerators, the tops, and the denominators, the bottoms. So what I get here is 10, the square root of 5, over the square root of 5 squared. So that square root and the square, they cancel each other out. So I have a 10 square root of 5. Oh, yes, okay, over 5. Sorry, my brain's one step ahead there. I'm almost done. So I don't have a square root anymore in the denominator, but 10 divided by 5 is just 2. So I'm going to write this as 2 square root of 5. So I've reduced the fraction, and that's going to be my final answer there. A little bit different here on the next problem. I have two terms down there in the denominator, a square root of x minus a square root of y. There's no way for me to split this fraction up because of that denominator. So what I'm going to do is I'm actually going to multiply by what we call the conjugate. So it's the same look as what I have down there in the denominator, but I'm going to put a plus sign instead of a minus, and we'll see what happens. So I'm going to multiply by the square root of x plus the square root of y. This is like a FOIL type thing here, so it's the whole quantities. Let's quantity this. And the square root of x plus the square root of y. So let's talk for a second just about the bottom here. Okay, when I FOIL that, I get the square root of x squared. That's going to turn into just an x. Minus the square root of x, square root of y, that's my inner terms, plus the square root of x, square root of y, that's my outer terms, and minus the square root of y squared. Okay, so what I see is that these two terms together, these equal 0. All right. And so what I'm going to come out of there with is just an x minus a y in the denominator. So let's go ahead and we'll pop that up here, and we're going to have 8 times x minus y squared over, the square root of x plus the square root of y, all divided by an x minus a y. That's from down here, all right? Alrighty, so what I notice next is I notice that I have a term up here that's x minus y and a term down here that's x minus y. There's two of them on the top, so I'm going to reduce. I'm going to cross one out on the top and one out on the bottom. This becomes a 1. So I end up with an 8 times an x minus a y times my square root of x plus my square root of y. So make sure you reduce for Canvas, or for Pearson, it will mark you wrong if you don't, like on the 10 over the 5 and on this one with your x minus y terms, right? Hopefully that helps on rationalizing the denominators. The next one is adding and subtracting rational functions. So what I want to do here is I'm going to kind of rewrite this and leave a little bit of space. I have 3 over a 16x. I'm going to say plus a 5 over 24x squared. So what I'm looking for here is a common denominator. Let's look at the numbers first. I notice that 16 times 3 is equal to 48, and so is 24 times 2. Okay, so what I'm going to do first is I'm going to multiply the first one by 3 over 3. That'll get me a 48x there. My second one by a 2 over 2. That's going to get me a 48x squared. Now I still need another x in the denominator on the first term, so let's put an x over an x here. That'll get me a 48x squared in both of the terms. All right, so back to all purple. Again, multiplying numerators, I get a 9x over my 48x squared plus a 10 over my 48x squared. Since the denominators now match, I can put the two numerators together, so I get a 9x plus 10 over my 48x squared. And that right there is my answer. Nifty, right? All right, I know, it's fun, right? Fractions are fun. All right, domain and range. So domain, remember, this is my possible x values. What can I put in there? So there's a few limitations that we have. If I take a look at our first one, f of x is equal to 2x minus 4, I cannot think of any numbers that I can't put in there. And that goes for any polynomial. So if I have an x squared minus 2, as long as there's no denominator, no square root hanging out, I don't have any concerns, which leads us to 2 and 3. But what I'm going to say is my domain here is going to be from negative infinity to infinity, and that's going to be written in interval notation there. If I look at the second one of my special cases, the 7 doesn't worry me, but here what I'm thinking is this denominator right here, I don't think that x squared, it can't equal 0, because if it did, I would be dividing by a 0. So let's solve for that. If x squared does not equal 0, then x does not equal 0. Okay, I took the square root of both sides, and I get 0 for my answers. This would be if I wanted to write it as an inequality. If I want to write it in interval notation, depending on what it's asking for, and Pearson does ask for a specific part, I think it was interval for this, I would say negative infinity, remember to use a parentheses right there, and a parentheses here. I don't want to include 0, so I'm going to use a parentheses, unioned with 0 to infinity. Okay. Keep an eye out on that union sign. You can't just use a U. I know it looks a lot alike, but you have to use the little union sign down at the bottom in Pearson, down by their little tools. And make sure that you have those parentheses there. Don't use brackets, all right? Otherwise, we'd be including 0, and that would throw us all off. Alrighty. The next one, here I'm thinking that whatever's inside, it has to be greater than or equal to 0, because I cannot take a square root of a negative number, right? So that's what I'm thinking here. I'm just going to make lines so we can see. So what I'm going to do is I'm going to say 2x minus 4 is greater than or equal to 0. If I add 4 to both sides, I get 2x is greater than or equal to 4. And then if I divide both sides by a 2, I get an x is, oopsie, greater than or equal to 2. That would be if I wanted it as an inequality. I can also write it in interval notation as, this time I'm going to put a bracket there because I want to include 2 all the way up to infinity. If you're not sure whether it's going to positive infinity or if I would go from negative infinity up to and including 2, pop in a number. 3. Is it greater than 2? It is. Okay, so I'm going the right direction. All right. All good with those. So really what you're looking out for there is you're looking out for when this equals 0, and you're looking for when this, I don't want it to be negative, all right? Not less than 0. All right. The next one in the example here with the graph, I want to find the domain and range of the graphed function. Again, remember the domain is the possible x values, or the x values that are there. So if I'm looking at the graph, what I see is it goes from negative 4, and that includes negative 4, all the way up to, including everything, all the way up to positive 4, right? But nothing else. So if I want to write that one in interval notation, I'm going to write from negative 4 to positive 4. I'm using brackets on the end because I'm including the negative and positive 4 because those are solid dots. If they were open dots, I would exclude them and use parentheses. I can also write this one as an inequality, and I believe this is the one that Pearson has you write that way, as negative 4 is less than or equal to x, which is less than or equal to 4. So that's my domain. If I'm looking for my range, I'm looking at my possible y values. So here, what I'm looking at is that my lowest y value that I see is here at 0. Again, these are solid dots. and it goes all the way up to, keep an eye on their graphs, this is 4, 5, and 6, 7, and 8. So this is 6. So I'm going to go from 0 to 6 here. So in interval notation, I'd have 0 and 6, including both of them. Or if I want to write it as an inequality, I would say 0 is less than or equal to y, which is less than or equal to 6. Alrighty, we're zipping along. The vertical line test. The vertical line test tells us whether or not we have a function. And remember, for a function, I get 1y for every x. So in order to know whether or not I have a function, I use the vertical line test and see if I intersect at each and every point just once, or if I intersect more than once. So if I draw a vertical line here, I can put it there. I only intersect once. No matter where I move it, it still only intersects once, right? I can move it around to anywhere. It only intersects once. So this very first one is, yes, it passes the vertical line test. It is a function. If I go ahead and try it over here with this particular graph, you can see that, let me zoom in a bit. You can see that it doesn't pass the vertical line test here. I intersect twice. Here I intersect twice. You can tell that I did the video before. There's a dot. Here I did. I don't care that I intersect 0 times over here. If I fail this once, the vertical line test once, if I intersect more than once at any x value, then we're done. So here I'm going to say no, not a function. All good? All right. Slope. Remember, if I'm looking for the slope of the line between 2 points, what I'm looking at is y2 minus y1 over x2 minus x1. So let's take the example here. I'm going to find the slope between the point negative 4, 2, or negative 2, and negative 6, negative 6. I like to label these as x1, y1, put a comma between them too, and x2, y2. It stops me from getting the first and second one. You could label either of them x1, y1, and x2, y2, but you don't want to mix and match, all right? So I can't have an x1, y2 combo. So if I'm looking at my slope, I'm going to say m is equal to y2, here is negative 6, minus my y1 is a negative 2, over a negative 6, my x2, minus negative 4, which is my x1. So there I'm going to get a negative 6 plus a 2 over a negative 6 plus a 4. That's going to be equal to a negative 4 over a negative 2, and that's going to reduce to just 2. And that's equal to my, slope. Okay. I'm going to use the slope here in a second to write the equation for a line. You can see there's 2 different equations we can use. I'll randomly switch them up. So this time I'm going to use the second one, the y minus y1 equals m times x minus x1. That one's called point slope. Both will give you the same answer. And this one's called slope intercept, and that's actually how we want to write it. So in the long term, we want it set up like that. So if you hear me talk about point slope or slope intercept form, you know what they are. Here again, I'm writing the equation for the line passing through negative 4, negative 2. That's my x1, y1. And negative 6, x2, y2, negative 6. You'll notice those points are exactly the same as above, so I already know that m equals 2 from above. Okay, we'll just bring it on down. All right, so all I need to do is I'm using the point slope form here. So I'm going to say y minus, I'm going to pick my y1. So y minus negative 2 equals 2, that's my m, times x, don't sub in for that one, minus negative 4. I'm only using one of the points, and you can use either one, you'll get the same answer. All right, so I get a y plus a 2 is equal to a 2 times an x plus a 4. Let's go over this way. So I get a y plus a 2 is equal to, we're going to distribute, so I'm going to pop this in here, a 2x plus, going over to here, 8, Subtracting 2 from both sides, I get y equals 2x plus 6. And that's going to be the equation for my line. Nifty, right? Let's see if I can get done with this perpendicular and parallel lines real quick. I know I'm at about 14 minutes, so I'll try and finish up here quick. If I'm looking for parallel, perpendicular, or neither, remember if I have parallel lines, then the slope of the first one is going to be equal to the slope of the second one. They never cross. All right, parallel lines are two lines that never cross. If I'm looking at perpendicular, I'm going to shorten it, then I'm looking at two lines that make a right angle to each other, kind of like the axes that we get. So there, I know that m of my first one is equal to negative 1 over m of my second one, my slopes. So my slopes are negative reciprocals of each other. If it's not either one of those, then it's neither. Okay? So if they're not related in either of those ways, then I'd go with neither. So let's solve these and find our slope. The best way to do it is to get it in that slope-intercept form from right up here. Okay, so let's solve these into slope-intercept form. I'm going to move this 5y to the other side, so I'm going to get a 15x plus 4 equals 5y. Now I'm going to divide both sides by 5, and I'm going to split that fraction. So I'm going to have a 15x, let's zoom in a bit, over 5, plus a 4 over 5 equals y. And that means if I move this up just a little bit, maybe, there we go, I can squish it in. I get a 3x plus a 4/5 equals y. What I'm really looking at here is on this one, my slope is equal to 3, okay? So that's what m equals here. So let's say m equals 3 off of this one. So that's my first one, m1 equals 3. Let's take a look at the second one. So here I'm going to go ahead and move my x and 9 to the other side. So I'm going to say that 3y is equal to 9 minus, well, let's write it in the same order, negative x plus 9. Now I'm going to divide both by 3. I'm going to get a y is equal to negative x over 3 plus a 9 over 3. And if I reduce this a little bit, what I'm going to do is I'm going to say y is equal to negative 1, because it has kind of like an implied 1. Oh, that's an ugly 1. Hold on. A 1 right here. Okay. It has an implied 1 up there. So I'm going to write it as a 1, negative 1/3 x plus 3. I really don't care again about that constant there. But what I do notice is that right here, this is my slope. So in this case, I'm going to say that, oh, I'm in highlighter mode. Hold on. Okay, I'm going to say that m2 is equal to negative 1/3. So what you can see is that they're negative reciprocals of each other, just like this. So m1 equals negative 1 over m2, since 3 is equal to negative 1 over 3. So these lines are perpendicular. Okay. All good? All right. So I'm going to stop there. I'm at 18 minutes, so it's a little long. I apologize for the length, but that gets us all the way through the information about the algebra, and then I'll do a separate one with the trigonometry. All right? Okay, talk to you soon. Thank you. Bye.